Hello everyone. Today we'll solve the numerical on this unsymmetrical faults. Okay. So let's see the numerical. 30 MVA 11 kilovolt 3-phase synchronous generator has a direct subtransient reactance of 25 per unit. Okay. Subtransient reactance is nothing but your positive sequence reactance. Okay, and the negative and the zero sequence reactances are 0.35 and zero point 0.1 per unit respectively. Okay, they have mentioned all this data. Let's take it. Okay, and next is the neutral of the generator is solidly grounded. Okay, the neutral of the generator is solidly grounded, meaning is, so this is solidly grounded means there is no neutral point. Okay, means there is no neutral reactance as well as your fault reactance, so that is equal to 0. Okay, and next, for this condition, determine the subtransient current, that is IA1, and the line to line voltages. Okay, at the fault under subtransient condition when double line to ground fault occurs, that is LLG fault, double line to ground fault occurs at the terminals of the generator. And we need to assume that the generator is unloaded and operating at a rated terminal voltage when the fault occurs. Meaning of this one indicates unloaded and operating at a rated terminal voltage when the fault occurs, means so this EA or positive sequence voltage will be 1 at an angle 0 per unit. Okay, that can be observed. Okay, let's take the data what they have specified. They have given 30 MVA 11 kilovolt subtransient reactance, that is a positive sequence they have given 0.25 per unit, and negative is 0.350 is zero point 0.1 per unit. Remember, all these are reactances. Okay, along with that JV is supposed to consider. And next, it is nothing but your impedance as well. Okay, so since by the given data generator is solidly grounded, means there is no fault impedance. For the double line to ground fault, we know this formula. Okay, IA1 equal to, just substitute the formula, you will get the result of this. IA1 is equal to EA divided by Z1 plus Z2 into Z0 plus 3ZF divided by Z2 plus Z0 plus 3ZF. We know, we have derived this equation, right? Now you know all these values, substitute here. Okay, you get by substitution and simplification, you get IA1 equal to 3.05 at an angle 90 degree. Okay, or it is nothing but minus 3.05 J also. Okay, in a polar form. This is, sorry, this is at a rectangular form and this is at a polar form. Okay, and simplify and let's see the answer what we get. Okay, and next let's take IA2. Okay, IA2, because this is the not only they have asked us to calculate subtransient current, so IA1 is enough, but they have asked afterwards line to line voltage also. Okay, VAB, VBC, VCA and all. So to calculate that, first we need to calculate phase voltages. To calculate phase voltages, we require first this symmetrical components. Okay, since you have calculated IA1, let's calculate IA2. You know this formula also, right? Formula is minus EA plus Z1 IA1 divided by Z2. You know all the values of this, substitute it and you get the answer of this. Okay, similarly, to take a IA naught, that is a zero sequence component current, okay, of that machine can be calculated by using this. Okay, formula, you get, this is the answer. Okay, and once you have calculated that, we can calculate a fault current as well. Okay, in a double line to ground fault, the in the double line to ground fault current will be equal to 3 times of your IA naught. Okay, IA naught we have calculated, just substitute in this formula, you get a fault current. Remember, this is in per unit. Let's express this one in actual current, that is in amperes. For that, we have to take a base current for that. Okay, to take a base current, there is base MVA, that is, you can write this one as like this also, 1000 into base MVA divided by root 3 into base kV. Okay, same way substitute all the values. You know 30 MVA rating of the machine, and 11 kilovolt given. Okay, by substituting it and calculating, you get a 1574.59 ampere. Okay, now you have got base current and actual per unit value. You can calculate actual fault current. IF will be equal to IF in per unit into base current. If you do, you will get 11.22 kilo ampere. And then we need to calculate IA, that is phase currents. Okay, to calculate phase currents, IA is equal to IA0 plus IA1 plus IA2. As you know, this will be almost all 0. Just do it and calculate. It comes 0.003J. Approximately we can take 0 ampere. Else you can keep as it is. Okay, this is IA. And next IB will be equal to this formula. Okay, IA0 plus A square IA1 is nothing but your IA, IB, IC will be equal to, okay, IA, IB, IC will be equal to, phase currents will be equal to your operating matrix, that is 1 1 1 1 A square A into 1 A square into your symmetrical components, that is IA0, IA1 and IA2. In the same way, if you expand this, you get a answers. Okay, so for this one, IB will be equal to IA0 plus A square IA1 plus A IA2. Okay, if you substitute all the values, we know it, and calculate, you get 4.798 and at an angle 131.72. You calculate and see the answers. Okay, IC will be equal to, same, expand that formula, you get IA0 plus A IA1 plus A square IA2. If you substitute the values, you get around this. Okay, and that is 4.79 at an angle 48.27 per unit. Okay, then we need to calculate line voltage, we require symmetrical components of voltages, and then we need to calculate a phase voltage as well. VA0, we know all the formulas, so minus ZA IA0, substitute the value and we get to answer VA1. Okay, but in this double line to ground fault, observe VA1 will be equal to VA2, therefore VA2 will be equal to 0.2375 per unit. These values all are of per unit. Okay, and then we can calculate a phase voltages by using this formula. VA, VB, VC is equal to 1 1 1 1 A square A 1 A square equal to VA0, VA1, VA2. Expand these values and you know the answer, values of each, and then substitute and you will get the answer. VA is equal to VA0, VA1 plus VA2, and then similarly VB will be equal to VA0 A square VA2 plus A VA2. Sorry, it is VA1 and then it is VA2. Okay, and then here also VC is equal to VA0 plus A VA1 plus A square VA2. And then we need to calculate, at last we need to calculate line to line voltages. To calculate line to line in a double line to ground fault, you observe your circuit diagram. So it will be VAB equal to VA minus VB, VAC is equal to VA minus VC, and VB minus VC. Okay, for VBC. So what we can calculate is, substitute, you know both the values and calculate it. Remember, these are all also in per unit. Now we need to get in actual voltages. Since you know the per unit values, you take just base voltage of this. Base voltage is nothing but 11 divided by root 3. Base voltage of that machine is 11. So divided by root 3 we have to do, and then we get a this answer. Okay, phase this is what your per unit value, and into your base voltage value you get a 4.52 kilovolts. Similarly, VAC as well as your VBC. Okay, thank you.